Hello friends, in this video we are going to discuss about the drift velocity expression with respect to the scattering time. So as we know that the drift velocity is denoted by Vd, and if we denote the scattering time as tau sc. Now we want to find a relation between the drift velocity and tau sc. Now what is scattering time? So for that, if we take a semiconductor like this, suppose this is a semiconductor bar. Now there are so many atoms bonded in this fashion. So this thing or this structure of atom will be repeated throughout the semiconductor. Now if I increase the temperature of the sample or the semiconductor material, then one of the covalent bond will be broken. In this way, so many covalent bonds can be broken due to this temperature. So during the breaking of covalent bond, we know some free electrons and holes will be generated. So in this way, so many electrons, that is free electrons and hole, will be generated. Now these free electrons will start moving in a random motion, like this. So during this random motion, this electron or free electron will get scattered, and scattering time means the average time between two scattering phenomena. So tau sc is the average time gap between two scattering phenomena. Now we know that if the average time of between the two scattering phenomena increases, then the drift velocity will also increase. So we can write that the drift velocity will be proportional to tau sc, and in the proportionality constant it comes as q into E divided by mn into tau sc, where q is the electronic charge, that is 1.6 into 10 to the power minus 19 coulomb, and mn is the effective mass of electron, and E, capital E, is the external electric field. If we apply external electric field, then it is capital D. So this is the relation between the drift velocity and the scattering time, and from this relation sometimes numerical on the gate questions come. So this is all about the drift velocity expression with respect to scattering time. Thank you.